You guys have a long finals period. Although I know some places have like we only had 1 week for finals, but I know like McGill, for example, had a whole month for finals.
We have 2
2 weeks.
weeks, not months.
Yeah. Yeah.
Ours is 1 month. 1 month.
Yeah, makes sense.
Well,
Okay.
we're good to go. So Peter or Chris, who wants to go first?
Oh wait, can I make an announcement before they go?
Yes.
Okay, so next week, like 99% sure, we're going to have a guest speaker. So we're going to have a professor from the University of Chicago named Alex Derlica Wagner.
In the chat, please.
Sorry.
Okay.
It's a hard name to spell. Okay, so this is who's coming. And he's a professor. He also works at Fermilab. And he's a survey scientist. And so he works a lot with surveys like DES, the Dark Energy Survey. Is he involved with LSST? Yeah, and he's involved with LSST. And so he knows a lot about surveys. He taught a class about survey science to me when I was at UChicago, and he's really cool. And so he's gonna come hopefully talk to us about how surveys are done and what we need to do for the All Sky survey. Adam, did you just copy and paste
Yeah,
the
so
name? Oh, okay. Got it.
Yeah.
Yeah. So
Well-
yeah, it's gonna be great.
Yeah, so please tell everyone to attend because we want to make sure that it's well attended. Also, this is
Yeah.
probably something that we're going to try to do on a regular basis, like once a month or once a quarter or something, to invite like experts in the field to talk about these topics. So we want to show them that we are engaged and yes, that we are engaged. So
Yeah. So please tell everyone to come.
Okay, we will. Thanks for making the efforts. And maybe I will suggest maybe Adam should post it on the WhatsApp group so that everybody sees it and prepare ahead of time.
Can do.
Thank you.
All right.
Ooh, PhD from Stanford. Slack. Okay.
All right. So then for today, I know we've got, so Chris has a cool Jupyter notebook to show us. And Peter, can you remind me again what you were presenting on?
And I'm to present on NumPy on the tutorial.
Yes, thank you.
Notebook tutorial, NumPy.
Yeah, so who would like to go?
Good evening, everyone.
Good evening, Chris.
I think mine is somehow more elementary because it has a Python start before it moved towards the more complex part. So maybe when I get to the matplots or maybe do the first matplot, let's say the first Jupyter notebook, I'll be very fast with that because I know we are all familiar with that. Then maybe when I get to matplot, then Peter might come in, and maybe when he's done, if there is time, which I doubt there will be no time, so maybe next time we might continue it when we have our pleasure time, or we might even fix another class other than Thursdays just to rush up, since it's not a main topic. It's not like the main thing. We are just trying to check what we know, so we just have a brush up and continue with more serious ones. So I don't know if it's comfortable for all of us like that.
Yeah, I think if we just walk through it together, I think it'll be useful for everybody. And since this recording is going up anyway for everyone to see, odds are it's, you know, not that elementary to somebody, and it could be really useful. So I think going through it, regardless, you don't have to sprint through it. We can go through it together, talk about it. Just kind of walk us through what it was, and kind of, you know, why you thought it was useful. So yeah, if you want to share your screen and start going through it, I think we should just jump right in.
Okay, thank you very much. Sorry, I see my screen.
Not yet. Oh,
Now we are.
It's starting.
Okay.
there we go.
Thank you. This the Jupyter notebook I sent on Slack channel was prepared by many persons, and most especially the SIP Python and Research Group that is organized by Professor Raja. So there were many tutors there, like Amanda, Antara, and co. Professor Raja was also there to watch everything. So though the data that was used wasn't the one for any of them, I mean the Galaxy data they collected and other things they worked on, but it's someone else's project, I think a thesis, that they try to share the code and learn more about it. So this is the Jupyter notebook I've sent in Slack. Now it has an astrolight section, and it has a more complex astronomy, not really complex, but the astrolight doesn't contain astronomy in the Jupyter notebook. Why the one that doesn't have astrolight has a little astronomy there. So in the Jupyter notebook, you'll be able to see many Jupyter notebooks. Like in that one I sent, in the zip, after unzipping, you'll be able to see many Jupyter notebooks like here. And then when you open them through, you have your own Jupyter, you can launch it. And when you open it, you'll be able to find the data, the program file, and the plot file. But I have just opened, because if I come here, you'll be able to see, this is my first page, my Jupyter. Okay, then the download, I saved it in a desktop. So once you click desktop, it opens. This is the SIP Python workshop. Then you have the data, the plot, and the program. I go straight to the program. So this is the first Jupyter notebook, which is it has, it's very long. It's a long file, but is a kind of a general summary of what Python is all about and what we can do with it. Sorry, it's loading. So it talked about variables, it talked about printing functions, it talked about lists, tuple, and most things. Then if we come there, you will see that everything here is in Markdown language, is in Markdown, which is not, we can't run a code there. We can only leave it as a text edited file. So when you click on this, you'll be able to see how these files were able to be formatted, like this one that is very bold, like these ones here. You see the source code, how they look like. So this is a header 1, header 2 with double hash and co. So this is how we can be able to put a link. So if you look at it very well, you'll be able to learn how to put a link and some other things here. Then if you just run this by pressing Shift Enter, or you run it there, it will display that in Markdown form. So here we have the line 1 in Jupyter Notebook. This is the print hello. So it's not like Python. Every language has their own flaws, but here we can see that though it's taking JavaScript, it's taking Java more time to print a hello world, but that doesn't mean that Java doesn't have its own advantage with the print and the string here, showing that everything here is a string. You'll be able to print that. So when we go down, this is just a markdown form trying to tell you more. Then we have a way of using Python as a calculator. We can add two numbers, divide, do so many things with Python. So, and the general form is the use of PEDMAS, though some persons call it PEMDAS, which P stands for parentheses, E stands for exponential. If you're using PEM, then M stands for multiplication, then division, addition, and subtraction. So in using Python as a calculator, you will see that when you write your values or when you be able to arrange your equations, your equations will be solved based on PEMDAS, like an example that was given here. So if you see you have something like 1 plus 2 times 3, the double star here doesn't mean if you want to raise a number to a power, you don't use the caret. A caret in Python means another thing, something like this. So you'll be able to see more of it, but is found in bitwise, like it's used more in bitwise. So, but if we are dealing with the Python calculator, so the P there in PEMDAS means parentheses first. So it is going to add everything in parentheses, which is 3. So after the addition, then the E is exponential, or the raised to power here, which is 3 raised to power 4. So when you do 3 raised to power 4, then it gives you a result. I think 3 raised to power 4 is 81. Then when you add, you first of all add 1 plus 2, which is 3. Then it means this is 3 times 81. Then whatever it gives you, you now remember that is now division or multiplication and division, though it's multiplication and division can go interchangeably. That's why I say it's PEMDAS or PEDMAS, but we just have to multiply 3 with 81 here and divide it by 5. Then we remove 6 from everything, which will give you 42.6. But on a normal, if you decide to just do this straightforward without using the PEMDAS acronym, you may get it wrong. So if you're not too sure in Python what to do, whether which should come first, you can always use brackets to group your numbers in order of preference that you want it to calculate, so which is the parentheses. So assigning values to variable names are a kind of label you give to a bus that contains your object. Since we know that everything in Python is object, so the 1 here, 2 here, strings, lists, everything is object. So this A is a kind of label that is actually trying to tell you that this bus has 1, it's inside. So you can actually remove the A here and put it in another bus. Let's say I decide to, even in this cell, I write A is equal to 3. You will see that it means I just removed the label A and I'm placing it in another bus that has 3 inside. And once you run this, if you are printing A will no longer, the present A will now be 3, not this one. Like if I decide to run another cell down, then A will be having 3, except I change it again. So that is it. Let's say I decide to, let me come to kernel here and restart all these. I've run this Jupyter Notebook, so it may be, I want to follow it sequentially, running the Jupyter Notebook sequentially. Seems it's delaying. Oh, okay, maybe it has run. So if I decide to print the A here, let's say, I'm going to have A to be 3. See that the present A is 3. Yeah, I've been able to restart my kernel. So then it means it's just a label trying to tell you more reason why a variable is a label to an object bus. So we can actually reassign values to a variable. So, and when we go down, this is how we can still print it. We can add two values. We can use the variable names to as a way of adding them. So this will just print 1 and 2 here. So when we go down, we can also do most of the things here. We have that. This is also another important thing while dealing with Python, because most times we have to add numbers to an existing value of a variable. So here, let's say we say that A is equals to 1, we print A to give you 1. Then this also means that you should just add 1 to A, which means A is already 1, 1 plus 1 will give you 2. So when you print the A of this third line, it will give you 2. So which is this 2 here, but when you print the first 8, it's going to give you 1. Then it can also go with multiplication. So if you don't want to write it this way, you can actually write, if you don't want to write it as A is equals to A times 3, you can actually write it as A times equals 3. So it's still the same thing. And when you print your A, you get 6. Here, what it means is that your A here, remember we are using the A here, which is 2. 2 times 3, this means 2 times 3. Or you come here and say it's 2 times 3, which is 6. You still reassign it to A. So in the string part, you can still do most of the things in string. Like we set a variable S to have the value or the object string or the object in class string to be hello world. So you can print the object. There are many attributes we have also with string, and these attributes are lower. We have the upper, we have the replace, we have other attributes too, like so. But with these ones, so you see this will give you, this will make the whole string here to have a lowercase, this will make the whole string here to have uppercase. Why this is trying to replace the string world with zip. So when you do that, you have, instead of having hello world, you have hello zip. So here we can concatenate strings also, though we can also concatenate numbers too. So if we concatenate, we have a string S which says hello world. So if we concatenate it with another string, which is it is a beautiful day, we can print the new string, and the new string will say hello world, it is a beautiful day. So we can also multiply strings. So you see that there is no space between world and hello here. This is what multiplication does when you're using ordinary Python, not the package NumPy, especially in numbers. So here we have this is how to input a value or demand a value input from um, maybe your client or another user. So once the person provides it, the split here converts the stuff, the input into a list and split it. So this will, all input values are always string. So as they are always string, if you print value here, you are going to get, like if I run this program here, you are going to, it's going to demand for an input. Let's say you say 1, 2, 3, 4 and click enter. You will see that the print value, the split here has made it to be in a list. If I should remove this split here by using the hashtag, you see that if I run it, once it demands, though it may show error because the other one may not continue since I'm no more dealing with, okay, you see, but for the print value, it has printed 1, 2, 3 as just a string you entered. So, and it's trying to tell you that the length of the string is 4. The length function don't have an offshot of 1. So it doesn't start from 0, it starts from 1. So you see this is 1, 2, 3, 4. So the length of the imputed number is 4. So, but it's showing you error here because of this program I'm running down here. So if I should remove this hashtag, the error will be corrected. So if I should just type 1, 2, 3, 4, maybe anything you type, you just get it. So here is saying that this is a for loop, which is actually used for iteration, mostly for a list or maybe a dictionary or a tuple, something as a set. So when you use for loop, you say for n in range 0. So range starts from 0, and range don't use the last digit. So remember the length of the value here is 4, is the length of the value as we have converted it to a list. So everything here is 1. Everything here is 1. It doesn't count it as 1, 2, 3 again. It counts like this 1, 1, except let's say I'm giving example of maybe, let me come here and add a cell downward. Then if I should, let's say a trial list, then I have something like 1, 2, 3, 4. Let's say something like this. Then if I should run this trial list, okay, I'm trying to say that if I decide to look for the length, I'm going to get that the length of this is 4. That is going to count after every comma, it will count 1. After every comma, it will add another 1. This is 1, 2, 3, 4, which is the length of this list. So, but if you see here, there is no comma here. It's just a single entity in a string form. So everything here is 1. Like if I should print the length of trial, I will have that will give me 4. So, but here the length of these values is going to be 1 because it is in string form and is only one element that is in that list. So with that, this n starts from 0 and it ends in a number less than length of value, because range starts when you use the range function. It starts from the first value is the starting value. The last value is not really the last value, but it ends in a value 1. It ends in a value that is less by 1. So when we said, so this n will start from 0. So for n in range, so n is 0 here. So it is going to come here, and the value, so it will come to the value. Remember the values here, the value from the values here is 1, 2, 3, 4, which is just 0, even though we know is 0 in terms of indexing, but 1 in terms of the length. So once it's 0, it will come here in indents, it will take the whole number here. So, and it will convert it to integer, that is this int here, and assign it to this. So this n here is also 0 here. 0 here, values n is a kind of trying to change the elements in a list. So you are trying to change the elements in the list values. So with this, you can create, with this, you'll be able to go to this list and choose 1, 2, 3, 4, convert it to integer, and reassign it to this value n. So when we go down to list, we'll now have, though we have seen how to create list above there, but here is more of how to index a list. So indexing a list starts from 0, 1, 2. So if I want to print this 0 here, so I'll just say, I'll just type x and have what? This bracket form and type maybe 0 or 1 or 2, depending on what I'm typing there. It will show the element that has that index. So if I should put 0 there, we see that just like the one here, you see that it will print out 0. The one here will print out 1, 2, 3. So, and so on. It goes like that. So it starts from 0 instead of 1, just like the length, in contrast to the length of an object, as when you're using length function. So here we have that the length of x here, we can even see that the length of s, if you count 1, 2, 3, 4, is meant to be 4. So it's going to give you that the length of s is 4 here. So we have another way of indexing, whereby we may not want to start from the front, we want to start from the back. You can use the negative values here for your indexing. So the negative one here means you are starting from the back, the last digit, -2, second to the last, and so on. So when you go down, you can see there is something also called slicing in a list, whereby you need some fraction of a list. You don't need everything in a list. So to get that fraction, so remember that when slicing, it starts from 0, it doesn't start from 1. So this means the first element, the second element, these two here is not inclusive. The first number here is always inclusive. The second one is not inclusive. So this, for that x, it is going to, for the s above, we have chosen the list s above, is going to give you the 0 and 1 alone, because 0 and 1, it's going to give you 0 and 1 alone. Then the one from 0 to 3 is going to give you the 0th element, the 1st element, and the 2nd element, just like that. If you didn't write any number at all before before the column, is going to assume you are starting from the first element and it's going to end in the second element. Then if you give a first value and you didn't give a last value, it's going to start from the second element. Remember, 1 means the second element in the list, while 0 means the first element in the list. So it's going to start from the second element in the list and finish up to the end part. So this one will start from the 0th element and end in a number before the last number. So with that, you'll be able to print all this. So this is another list. This is a way of changing an element in a list. So if you choose, let's say you want to change this 2 here to 48 to 486.1. So you just write the list name, the name of the list, or let's say the variable or the label having the list. Then you have your brackets here, your square brackets here. You have 1. 1 means you are trying to change this second element here. So, and you are changing it to 486.1. So with that, you see that 2 has been changed to 486.1. Is a way of changing an element in a list. So here we will be able to see that list doesn't contain only integers, but they have both integers, strings, other lists. It can even contain a dictionary, a tuple, and as many as you want. You can have list inside list inside list. So it's just like that, but that is only when the code gets tough. So, but here you have that your list A is a number, which is an integer, then a string, and another list. So you can print your list here. You have this. When you print, you want to print 1. Remember, in indexing, the first element has an index 0. So with the index 0, you have 1. So with that, so but the interesting part is this last part here, which means that if you want to get an element inside a list that is in another list, so you have to choose. So here means the first bracket here is trying to pick the index of the outer list you are talking about. Then the second bracket here is trying to pick the index of the inner list you are talking about. So it continues. So imagine maybe I have another list here inside again. Let's say I have something like this and something like this. So it's a list upon list. So this is just a 0th element. So to pick this, So I'll first of all come to, if I have 1, 2, 3. Okay, I think I need a third bracket here. So something like this. So if I have something like this, so you see that if I decide to say I'm printing A2, this is A0, A1, A2. So A2 is everything here. Then this 0 means I'm talking of the one in the inner list. So if I don't want to talk about the one in the inner list, let's say I'm talking about the last element. So let me use -1. So for that, let's say I say -1. So it means if I come to the outer list and go to the element with index 2, then I will now go to the last element, which is having 3 here. So the last element is having 3. Okay, let's say I have another element inside as 4. So I'll still need to enter inside again with maybe -1 again, just for me to capture 4. So maybe -1 here again. So if I run this program, it should be able to so this print A here in this number 9 line should be able to capture 4, except there is an error somewhere. So it should be able, it has captured 4 here. So this is how lists and indexing and slicing goes. So when you go down, we'll have, we are trying to use range and wrap a range inside the list. So a range is just an array. So Python, most times when dealing with Python, you have to deal with array of data. So these are just arrays of data. So it has a starting of 1 and it ends in 10, though 1 less than 10. Then it has a stepwise of 2. But this, if you go to Python documentary, or maybe you just sit in, that is how it is. So Professor Raja was able to tell us, and then Taraku, they were able to tell us that Python documentaries and Google, they're always our friend. Once you miss your step or you don't, you mustn't have everything off hand. So you can just, you know what you're looking for. So you just go check it on Google, come back and continue doing your work. So you can actually do same when you don't know why it's ending before 10, because some of the arrays might end in the exact stopping position. So here we have the list. So we have the range starting from 1, ending, having a stop at 10, even though it's 1 less than 10, and a stepwise of 2. So when you print this list, so you're using this list, we convert this array to a list form. So when you print the X, you have a list that has a stepwise of 2. So it will count 1. Instead of counting 2, it will jump 2 and count 3. Instead of counting 4, it will jump 4 and count 5. So that's why you got an odd numbers here. That's how you got an odd numbers here. So with these two, range, you mustn't put, because sometimes these functions, they write it in a way, though they're built-in functions, but they write it in a way that it can accommodate so many ways if you want. So here you see that we're only having one values. So the argument you might be using, so it means maybe they chose in their parentheses when defining the function, they have defined it in a way that if you give many arguments, it will be able to collect it and do the needful. So if you give one argument, it should be able to collect it and do the needful. So here you can see that we're only using one argument as 5. So this 5, and this argument is just the stopping argument. So it takes 5, it starts from 0, because it means that the default is 0 and the ending point is 5, which we always know is a bit less than 5, let's say 4. So, and it has a default stepwise of 1. So that is it. So if you choosing a single number, you should know that your default starting point is 0 and your default stepwise is 1, and it will end in a number less than 5, maybe less than the value you put. So that was how we're able to get 0, 1, 2, 3, and 4 here. So you can see that when trying to add to lists, when you say x plus y, you just have the list like this 1, 3, 5, 7 because you're adding x plus y. So you see that this is a bit disadvantage why using list, and why numpy is better off, because though we can still do the same thing with list, but it might involve you looping. So using for loop to grab each elements and maybe add, or maybe there may be other easy ways. But I think numpy, the one I saw in numpy was easier a bit, whereby you can, once you say s plus y, if you have defined your arrays, it will just add directly and put in the values there.
Hey,
So
Chris.
with this, yes.
So first of all, this is really useful. Like I did not expect there to be this much. So do you want to take just like 5 more minutes and just kind of highlight the sections, like kind of what this entire thing covers for the Python intro? And then I want to make sure we move to Peter so he has time to show us the section from the other tutorial. Is that okay?
Okay. Yes, yes. So this is just all about what you can do with lists and how you can add them, then append lists. So when you append through the back. So you are trying to add more elements. Then we have the tuple. It's almost like list, but it's just that is immutable, you don't change it. So we have the conditional and booleans, which has only 2 values, true or false. So while working with booleans, you will see that you can use numerical comparison operators like equal to, less than, greater than, less than or equal to, and co. Then this is a way of using conditional statements. If s is greater than 10, we have assigned s to be 5. If s is greater than 10, then do this, else do this. So with that, we have 2 types of loop in Python, the for loop and the while loop. So here you're using the while loop. So you should be very careful here so that you don't go indefinite. So sometimes if your computer hang, you have to look for a way to stop it, stop the action or close the program. So here is the my list. Then when trying to list or iterate through a list, you use the for loop, or maybe iterating through dictionary, just like I said before. So we now have the functions. This is how to define a function. You define a function. This is the function name. Don't forget the column here. So num is the function name. Why you use the diff, the keyword diff, then the function name. Return returns everything in this box here, just like this, and it returns n. So why sometimes you don't see some persons using return. So, but if you don't use return, no problem. Just that return makes it simpler. When you are calling the function somewhere, you just need a single stuff to call the function. But with this, with return, you'll be able to do it better. So if you don't use return, you just have to call the function. You can't use this print here because it won't work. So you have to just call the function like that. So that is how to define a function. Then here we're able to we're able to learn how to get the norm, which is the distance. So you'll be able to get the norm just like so after getting the norm, if you go down the most important one, here we are just able to know how to manipulate our list and get what we want. So importing module. So sometimes if you discover that what you are trying to write in Python has already been written, you just import it instead of trying to start up your own. So with that, you'll be able to achieve more other things. So when you import the mass module, this is a way of trying to Python, Jupyter Notebook and Python, they have cool documentaries that once you type help, open brackets, and what you want, then it will be able to give you a doc string of what the function is all about. So putting it all together, we're putting everything up there all together. So we're able to give the position of a galaxy, the x position, the y position, and the magnitude of a galaxy. So the magnitude is just the brightness, which is different from the luminosity, the total energy. So with this, we know that the first scientists that started, they used the backward method because the first that the person saw saying is the brightest, he gave it 1. So, and then later on he was giving 2, 3. So when discoveries continued, so the brighter objects became minus and 0 minus and go. So when you see a smaller number, it doesn't mean that it's less bright. It's just a way of assigning it. So with that, we have the S position, which is in degree. We have the Y position in degree, the magnitude also, which is the brightness. So here we see that this is just a way of saying your latitude, longitude. So as your longitude is same as your x-axis, because we know from our globe, how to locate points in the globe. So you'll be able to see that your longitude increases towards the right to 90, then towards the left to 90. Then while your latitude increases towards the North Pole to 90, your latitude increases towards the North Pole to 90 and towards the South Pole to 90. So with these, we have them in degrees. But when we go down, we are trying to identify, trying to look through all this, because it's the same star, a star, the X shows the X position of the star, Y shows the Y position of the star, then the magnitude shows the brightness of that particular star. So this is a follow, trying to iterate through this. So just like I've discussed that how to do this above. So the I here, so for I in range this, so you know that if you count this, it has 20 galaxies there. So with that, we have maybe 0 to 19 here, that is the length here. So 0, I equals to 0. When you put 0 here, the S value, it will give you the S value, the first S value there. So if you do it same and run the program, you will have all these down here. So when you come here, so we are trying to now do something funny again. So is a kind of trying to know the galaxies that are bright and trying to know those ones that are not far away from the center. So we said the center was chosen to be 182 point stuff. This floating numbers. So we have the magnitude. Let's say the greatest magnitude we want is 23. So every other magnitude less than 23 are brighter. Just like I said, they are inverse somehow. So with that, we'll be able to see that in this position, we are trying to, this is an equation that gives us the small angle approximation, that is the angular difference between 2 points in a sphere. So this is small angle approximation. So with that, we'll be able to, since we have known the position S, the position Y, and the magnitude, once we take this difference from the X center and Y center, we'll be able to see the angular difference of those two galaxies. So when we do it that way, this is a function written to get that. So this is a difference. X2 here means the center, S1 here means the galaxy position, S position. So same with Y. So with that mass formula there, and this is still this. So we have imported our mass before. Without it, this will not run. So mass the square roots, then this. So remember also that while dealing with trigonometries, that in Python you have to convert them to radian to get your actual value. So with that, we converted, because this is the only one that involves cos, others doesn't involve trig. So we're only interested in converting the degree here to radians. So after working, you have that. So this is just to return the separation there. So when we want to call the function, it will be easier for us. So this is to close enough list. We just have two lists to know the close enough list of galaxies and those galaxies that are bright enough. So with that, we also have to look again. With this, we have from our iteration 0, 0, this. So we have to assign, this is a way of calling that function separation there. So once you assign it, the X center has been defined up, the Y center has been defined up. Once you call this function, once we call this function here, it will be able to do the needful. So with this, it will assign X, Y, X center, and Y center to that function there, and also call the function. So with that, you will see that target I, which means like 0, the target 0 has a separation of, so just, is it that we print out, remember before we always print out separation or print out the function, after returning it we print, but here we don't need to print, we just put it here. So it will just print, it will just show all this there. So with that, we'll be able to see different targets and their separations once we run this program. So we want to know if these targets are actually less. So when you say if separation is less than distance limit, then if it is true, it will just return true here. If this is true, it will just return true. If not, it will return false. So we now say if this is true and this is true, which means it is true. True and true is true. True or false can be is true. So just like that, as is written above. So with that, so for anyone that is close and anyone that is bright, so they are both true, so it will return true, and will now count as one, which is yes, we have gotten our first galaxy that is close and that is bright. So with that, we will be able to append such a galaxy. So when we append true there, so we are appending true or false there. So because remember that this is an outside loop, and outside is not inside this if. So this will append both true and false, but this count will only record the true values. So with that, when we go down, we'll be able to see that we can count the number of galaxies that are bright and at the same time close, so and observable. So with that count in that if statement, why this one record all true and false. So with that, we can print them, say that there are 10 targets that are observable. This observable means that are bright and also close to the center. So with this, we'll be able to have, so here we are trying to also get the, so here they say, so we have found the 10 observable targets, but which one are they? We don't actually know the particular one. We just have true, false, true, false, true, false in the previous one. So we want to know actually which galaxies are these galaxies. So we have to loop again. So if you print this, you discover you just be having true, 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 false, 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 which are up to 20 here. So, but if you now say for I in range this closed list is about 20, so it will start from 0 to 19 and do the same. So it's close. So if this in this, it will just put the check the first element and the first element here. If the both first element that is close and is bright, if they are all true, so this is, it will now count that particular index. So once it counts that particular index, it has recorded the index. With the index, you'll be able to print the particular galaxy that is doing that. So with that, that was how all these were printed. So if you go down, so what didn't we cover? We have not covered plotting, and sometimes we didn't cover much of those things in total. So here we have the matplotlib. I will just say a little. I'll just say this one. So maybe if folk can talk, so we'll know, and maybe next time I will have to talk more on all that since I've already finished the first page. So here we have our line matplot importation. So you can either use this or this, but this one is most preferable. So though they are all good. So with that, we are having a scatter plot in Matplotlib. We know that Matplotlib is a package, which is a combination of different modules that can be installed in your system, and you can run it. So it's different from module because a single module might just be a script in another file. So you can just move it to another script by just calling the function. So with this, we have this package matplotlib. You have to import it by saying from matplotlib import pyplot. Though you can also say import matplotlib.pyplot as plt. So anyhow you do it, then this is the first element says always your x values you want to plot, and this one is always your y values you want to plot. Then this is your magnitude. This is color mapping. We don't have only this R. We have other ones like plasma and others. So this is the size of this shape, this cycle you are seeing here. This is the marker that tells you it's a cycle. So you can also choose other ones that are not cycle. This is the line width. This is the alpha, is a kind of the opacity of that color or and others. So when you want to have this scatter plot, so this is the color bar. which produces this long color here. And once you're using that color bar, you remember that you have a color map. You can decide to choose your color map here. So, and this is just a kind of 3D because it has both S, Y, and the color map shows you the magnitude. So it's a better way of having a 3D plot. So here you can now have label your X label, PLT does X label. If you check down, you see that your X label has RA degree, which is just the string we have written here. So your Y label is this. Then this is the color bar set label. You're trying to label this color bar here. If you change this magnitude, let's say mag, you will see that the magnitude in that color label we change to mag. Because I've not been running my program, if I run this, I may have error because I've not run the maths and others. So, but it's just to tell you that this magnitude is as a result of something, the string here, magnitude. Why the title here gave these target candidates. So, and I've explained here, the alpha is going to make it more opaque. So it's always a float, so 0 0.1 or 0 point something to, I think maybe it ends in 1.0, something like that. So, which is the opacity, because if I should change this maybe to 0 0.2, this blue, you'll not be seeing it very well. It will look so light. So the higher the number, the more opaque it is, or the more thick the color is, something like that. So that is for the first Jupyter notebook. These are just terms in Python you may be able to learn. Thank you. Maybe next time we'll talk more about Matplotlib.
Thank you, Chris.
That was awesome. Thank you. And Chris did post these notebooks on Slack. So if you want to go through them by yourselves, they're there. Right, Chris?
Yeah.
They're in the All Sky channel.
Yeah.
All right. Dang, there was a lot there. That was awesome.
That was great. Yeah, thank you.
All right, Peter, are you ready?
Hello. Okay. Okay, let me share my screen. Can you all see my screen now?
Yes.
Okay. All right. To talk on NumPy, and this is the beginning of the Jupyter Notebook tutorial. So I didn't go through all that. So the thing is, in summary, I didn't really understand the codes that much, but I was able to do something little. And so, okay, I started by running the code. This is a magic command, %sign pylab inline. Then import numpy as MP. So this line is actually importing the numpy package. And instead of each time you want to use the numpy, instead of typing completely numpy, we can use MP since we have told it to import numpy as MP. Then import matplotlib as .pyplot as PLT. This one is also for plotting. So we're importing it as PLT. So each time you want to use this module, you use PLT. So so this is a section I was asked to give a talk on. So this code is actually defining a function. So this is an example on how to compute the sum of two lists. Like Chris said, a list is is an object that has different values separated by comma. So the def keyword is used to define a function, and the function is add. So these are the arguments x and y. Then this add is equal to 0 is we're giving it an initial value. This variable add or this function add, we're giving an initial value of 0. Then for element, this is a for loop. For element underscore s in x. So I think this is an arbitrary list that I can't see on the Jupyter Notebook tutorial, but I want to believe that this for elements, so this element underscore x is actually an imaginary variable in this list x. So add is equal to add plus this add now will not be this 0 plus elements, that is each value of the list x. So the same thing for the y list. So then this return add returns the overall addition of x and y list. So basically the code that I was given, it does not have this, is it asterisk sign? And then this. So arrange, okay, I think it does not have this too. Yeah, so it is just something like this. So a range, you are defining a list, and this is equal to range, open parenthesis 0, 100. So I think is we're picking values starting from 0 to 100, and the step size by default will start from 1. And if we print the lists using Shift Enter, it's an error. Oh, okay, I need to run this line first. Okay. This. Okay, so we have it now. So it's just spitting out this same thing, and I was kind of confused here. And why is not giving me the value of this my list? So I went online, and a way to do that is it to spit it out, something like that. I've forgotten what it's called. Okay, is it okay? Give it, put an asterisk there. Then we have your brackets. Then another bracket. So if I run this, it runs. Then if I run this, so it's now spitting out the list the way I was expecting it. So these are the values of this list. So here, this time it's used is a function used to calculate the time it takes for a particular snippet of code to run. So you can use it to like what's the right word to use now? That is know how effective your line of codes are. So so this is time it, and I don't really know what this minus n10, but I want to believe is for the particular number of iterations that this line of code is to go. This so we have a variable sum underscore 1 is equal to add, open parenthesis, my list, comma, my list. So I think it's trying to add this list to itself. So, and when I run the code, this is what it's giving me. I don't really understand what it means. We have 16.1 microsecond plus or minus 6.65 microsecond per loop. This, I don't really understand what it means.
So we can like quickly go over that. So you're right that the N10 says that it should run the add function 10 times. And so since it's running it 10 times, each time your computer computes like sum underscore 1, it takes it some time, right? So it takes it like, let's say 15 microseconds, right? But if it runs it 10 times, so it reruns that cell basically 10 times, right? So if it runs it another time, maybe the next time it takes it 17 microseconds, and the third time it takes it 18 microseconds, and the fourth time it is really fast and it takes it 10 microseconds. So it's just showing that how long did it take each of those 10 times to run this addition function. And so it says, okay, on average, it took 16 microseconds to run it with a standard deviation of 6.65 microseconds. So that's all it's saying. It's just trying to calculate how fast you can calculate that function.
Okay.
Does that make sense?
Yes, it does. So what this add function is doing is adding this list to itself, right?
It's adding each element in the list to itself. So it's adding 0 plus 1 plus 2 plus 3 plus 4, and it is doing that twice.
Oh, okay. Okay.
Yeah. So you can print sum underscore 1 and see what it gives you.
Oh, okay.
And then yeah. Try running it. Oh, print. So since sum 1 is not defined, just define it right above it. So do sum underscore 1 equals add. Yeah, so copy paste that part. Yeah, that part. So copy it and just put it in the, just put it above the print statement. Yeah, now try. Yeah, there you go.
Thank you.
Yep.
So the next cell is an example using NumPy arrays. Okay. This my underscore array is a variable, and the value of the variable is MP, which like we imported NumPy as MP. So we're calling this where is it? Okay, here. So this is the NumPy. And instead of typing NumPy, we are using MP now. So MP.arrange. So it's going to take values starting from 0 to 100 using stepwise of 1. And when you print this variable, my underscore array, this MP not defined. Okay, I need to run this cell. Where is it? Okay. So these are the values starting from 0 to 99. 100 is not inclusive. So the stepwise is 1. So if you change this 1 to 2, it's going to just take is it even numbers? 0, 2, 4, like that to 98. So then this time it also is also calculating the time it take to add these arrays to themselves. So let me run it. This is it. And okay, just like we did, this minus n 10 times is the number of iterations. So let's see what this okay. Let's see what this will give us. Copy.
Try running it. Try running that cell again.
Okay, I have. Okay. I
Okay.
have.
Yeah, that makes more sense. Okay. Yeah.
So maybe let's see what's the value of this mp.sum array plus array. This, okay, let's give it a variable. What should we call it? Sum underscore array. We call this. Okay. Okay, I need to print it out. Print. So, so this is the sum of the array. But I have a question here. Hello?
Go ahead. Yeah.
Yeah, the question is, I think it seems each time I run this time it changes, the time changes. I don't know if you've noticed. Maybe let me run it again and see. Okay, it's changing, yeah.
The time will change. It's not gonna be the same exact thing every time because things depend on like what your processor is doing at the time, what it's running, how your computer like does these calculations. It's not gonna be constant, but it should
Right.
be pretty close.
Okay.
Like it's not gonna change from like 36 microseconds to like 2 seconds all of a sudden, unless you
Oh.
have some like really like non-efficient like memory usage or whatever in your computer. But it's going to change like within like error, quote unquote, you could say.
Okay.
Within your standard deviation.
Yeah, yeah.
So the
Okay.
point of this exercise is to show that NumPy is a lot faster. Like the reason we use NumPy is that it's a lot faster than manually adding lists. So if you compare the time it took to do that with the time it took to calculate the sum in the list with our add function, well,
Yeah.
actually, in this case, the list was faster, which is strange. But usually try doing n 100 so that we get like more consistent. Instead of 10 iterations, put 100 in both.
Okay.
Yeah,
Okay.
yeah. Let's see. And run both of them.
Okay.
Please. Okay, 43.2. So it's smaller standard deviation now. Let's see with this. Okay, so you can see that it's faster. Like
It's
NumPy, yeah.
Okay. That's true. Okay. I get the idea behind this tutorial now.
Mhm.
Thank you.
Yeah, no, that's awesome.
Okay. So for the exercise, I don't know, but it seems this is the answer to the exercise, right?
Yeah,
Like I've loaded the exercise and it seems this is the solution for exercise 1.
that's right. Yeah.
Okay. I don't know, maybe let me open okay. Since I have it here already. Sorry, just a moment. Okay. Oh, okay. Seems I've already run the code. I think it's the same. I wanted to see how it is when I downloaded it, but when I downloaded it, this code was not showing in this cell. So I wanted to ask question what the cell was trying to do. I don't know if you get what I'm trying to say.
Yeah, so it wasn't like there initially, and the way that you like can load it is, so it's loaded now, but you can load it by, you see the first line, it's like hashed out, like it's commented out.
Yes.
And you know how ex1.py is in the same folder?
Yes.
Yeah. So if you wanted to, like, if there was nothing there and you wanted to load the code to see the answer, you would uncomment that line and then run the code. So you
The
can like
code.
try copy pasting the percent load ex1.py. So copy it and then paste it in like a new cell.
Okay.
Yeah.
Okay, insert cell below.
Yeah. And so run that. Yeah, see, it like loads it for you.
Let's say, okay.
Yeah. But like the point of this one was just so that like you try out the exercise, and then if you're stuck or once you're done, you can compare it to like the answer or one of the answers. Yeah.
But I don't really understand this code. Please, can you explain to us?
Yeah. So here, like the exercise asked to calculate, if you go a little, scroll a little up, it asks to compute the product element by element of a 2x2 list, right?
Okay.
So we want to do, you know how before we did the addition of every element in two lists? Now we want to do the multiplication of every element in both lists without using NumPy. So here it's just with using like lists, right? So what it's saying is you want to, it's saying, okay, let's call a new list, or let's create a new variable called new list that is equal to list one.
Okay.
And if you want to do like a loop of the element by element product of two lists, they should be the same size, is what it's saying here. So if the length of list one is exactly equal to the length of list two, then for every element, so you see how it's a for loop, right?
Yes.
But it's a two for loop, right? There's a for loop inside a for loop. And so we're measuring, since it's a 2x2 list, it's measuring every row, right? And every column. So it's taking every element inside your like square, right? Because it's 2x2. And it's just multiplying them together.
Okay.
So yeah, so for I in I comma row in enumerate list one, and then inside, so now it's taking every row, right? It's saying, okay, like for every row, we are now going to run another for loop, and in each row, we want each element inside the row, right? So this is kind of what Chris was talking about before, like double indexing. Like you see how there's an index I and an index J.
J.
Yeah.
Yes.
So that's like the nested lists, basically. A nested list is just a two-dimensional list, right? Because you have in one dimension, it's like an image, right? You have rows, you have a large list, and you have a bunch of smaller lists inside that tell you like each row of your image. So it's the same thing. And that's why you need the two indexes, because you want to grab every element, which is the first index tells you which row you're grabbing, and the second index tells you which element inside that second list you're grabbing. So it's kind of like hard to explain, although Chris did a great job of it and I'm just struggling here. But I think the best way to understand what it does is to try it out.
Okay.
So Yeah.
Alright. So for this cell, in this example, we will split a random array into 3 different categories, taking advantage of the NumPy mask. Okay, I think I stopped here. So downwards, I don't really understand what it's saying or doing. So maybe I will have to like go through it again, then represent it like maybe 5 more times, go through it, understand it very well, then I represent it again.
Okay.
All right.
Thank you. That was also awesome. I
Thank
did
you.
a little clapping. And you stopped right at 12:30, so good timing.
Oh, okay. So can I stop sharing my screen now?
You're good.
Yes.
Okay.
All right, I'll have this meeting uploaded. And so anybody that wants to go through the notebook that Chris shared, it's in the All Sky Survey channel. And the notebook that Peter was sharing, that one is also in the All Sky Survey channel. I don't know how far you have to scroll up. It might be under pinned items. Let me check now. So we have that. Oh, actually, you don't have to scroll up far at all. I put the link to it. It's only 2 messages above the zip file for Chris. So you guys can access both of those and go through them all on your own, get together as a group on your own time when it works for you, go through them together. Either way, there is quite a bit to review and to learn. I can already tell you that I plan to go through both myself this week. But yeah, so does anybody have any immediate questions before we wrap up?
What I'll say is during the week, maybe Monday or so, if I can, maybe I'll hit Adam or Amanda or Kasia up so that you get to explain that NumPy section to me so I can present it very well again.
Sounds good.
Yeah. Sounds great. Yeah, please hit us up.
I also wanted to ask if I don't know if we can actually rush this because actually mine um, Jupyter notebooks I shared, they are very large, like very, very large. You see, though the largest was the one we covered, but which was actually the simplest. So next time it won't be easy like this. So sometimes it will involve things like parabola. You have to look for a way to be sketching some things, getting the sprung Russell diagram, and everybody has to be involved because I'll not be able to do it again. We'll see how it goes. So, like, I don't know if it might be taking much of our time. Maybe we may have time, just like Peter suggested, maybe on Monday, if it's something we could have that day, maybe after the teaching of Peter, maybe if I can share maybe the second and third, or maybe the second, then before we know it, we'll be able to, those Jupyter notebooks shouldn't be what should delay us to continue what GLAS has to offer, because I know GLAS has to offer bigger. Is a question and suggestion though.
Yeah, we can do like the hack sessions or something if you guys wanted to, like on Monday. I know that next Thursday we are having the speaker that Katya mentioned. So they will be talking about surveys in general, but otherwise, yeah, it's important to get a handle on how Python works. So this is helpful, I think. And yeah, we would definitely love like if we can see like more participation and do like a hack session type of thing. Or maybe we can take like I don't know, like half an hour for people to do their own code, and then we can come together and show each other like what we did. I don't know.
That sounds like a great idea. So yeah, so Peter, if you want to just reach out on Monday, and next Thursday, I don't know if this, I doubt our guest speaker, are we going to be talking to them for the entire hour and a half, just 1 hour? I
I
would
guess
assume in less than an hour.
depends how many questions people have.
Sure.
Yeah.
So if you guys get bombarded from notifications from me over the next 7 days, reminding everybody that we want as many people there next Thursday as possible. Yeah, sorry, but you're going to be getting a lot of notifications from me.
Yes, please come. Alex is wonderful. He's really nice. And I'm sure he'll be really happy to talk to you.
Please also ask questions, like don't be shy.
Yes, I told him that we want to have time at the end for questions. So please come armed with questions. You get to talk to a real life survey scientist who has worked on some of the biggest astronomical surveys there are. It's super cool. Get pumped.
Okay, so I think we are all set for today. If anything else pops up or you guys think of anything, any types of suggestions or questions, feel free to just throw them in Slack, and we'll see all of you next Thursday for the guest speaker.
All right.
Ooh, ooh.
Thank you everybody for coming around.
Thank you.
Yeah, thank you guys for presenting. That was awesome.